All right, Mr. Midas is here, and this is the last one in 5-5 for BC Calculus. This integration involving natural log functions, part 3. So we'll take a look at some other ones that we could use the natural log for, and just to remind you all that the integral of 1 over x dx is equal to the natural log of the absolute value of x plus c. All right, so let's take a look at a couple of problems here that we would use those for. So we're going to go ahead and integrate, cotangent x. So what do we got to do this? Well, we need it to be like 1 over x something, right? So we're going to change cotangent to cosine of x over sine of x dx. And notice that the derivative of sine is cosine, right? So we actually have a hook on right there already. So we're going to have, this is going to be equal to the natural log of absolute value of sine of x plus c, and that's it. Okay? So in general, if you want to integrate cotangent x, it's equal to that. All right, well, what if we want to integrate tangent x? Well, if we want to integrate tangent x, we'll do the same thing, right? The integral of tangent x is equal to the integral of sine over cosine. But notice here that in this case, the derivative of cosine is negative sine. So I actually need a negative here and a negative there so that I can make this my hook on. And so then this is going to be negative ln of cosine x plus c, absolute value of cosine x plus c. So if you wanted to, you could just remember that you got to do that. Oh man, I cannot. My computer here is going a little slow for some reason. So that's why you see that as I go in and out here, it's not quite doing what I want it to do at the time. So you can memorize these if you want to. Put it in one of those flashcard things that you want to try to start to memorize for the AP exam. That the integral of tangent x is negative ln cosine x, or the antiderivative of tangent x, or the antiderivative of cotangent x is equal to the natural log of absolute value of sine of x plus c. So let's take a look at a few that we could possibly use these little formulas here that I just gone over. So let's say we want to integrate the tangent of 2x, all right? So we know that the integral of tangent is negative ln cosine, absolute value cosine x. So we just have to deal with this 2x in here. So we're going to use a reverse chain rule. So we need a 2 right here and a 1/2 out there. And then we're going to get right here, right there. So we've got negative, I don't want to forget my 1/2 that was out there, 1/2 ln of absolute value of cosine 2x plus c. Okay. So let's do the next one. This is tangent squared. Move this over here so we can see it. Okay, so the integral of tangent squared x. Ooh, that's tricky. If I put this as tangent x squared, I don't have any hook on because the derivative of tangent is secant squared, so that doesn't help me. If I do tangent and tangent, the derivative of tangent is still secant squared, so that doesn't help me. So I've got to reach into my bag of tricks here and use a trig identity. Tangent squared x is secant squared x minus 1. Okay, that's a trig identity that we learned back in pre-cal. So we're going to have the integral of secant squared x dx minus the integral of 1 dx. And the integral of secant squared, well, actually, I know what the integral of secant squared is. That's just tangent. And the integral of that's x. We'll see. You know what? I didn't even have to use ln in this one. So that was a tricky one, right? I went from integral of tangent x, which needed an ln, to the integral of tangent squared x, which didn't need an ln at the end, right? Because I could convert it into an identity. So we got to be careful at which one we're using and how we're looking at these these integrations, okay? So start to kind of see the connections between the derivative and the antiderivative. There's the bell. So it's actually time for me to go, but I'll talk to you guys later. I think that was my last problem anyway in this video. So we'll see you soon, and good luck in calculus. Bye, guys.